magnetic properties?
Yes, ma'am.
Okay, I think I have just started the magnetic properties, right?
Yes, ma'am.
Okay, okay. So magnetic properties. So when we talk about the magnetic properties, there are two types of magnetic properties. Okay, two types of magnetic properties. First one is your paramagnetic and the second one is your diamagnetic, right? Paramagnetic क्या होते हैं? Where there is unpaired electron is present. What is paramagnetic? When there is an unpaired electron which is present in the your orbitals. But the diamagnetic is that when there is all unpaired electrons. See, no unpaired electrons. Just suppose we have 1, 2, 3, 4, 5. It's D10. Okay, the configuration is D10. So, and if the your 1, 2, 3, 4, 5. So if the your D6. Okay, D6 and D10, between these two, let's check which one is paramagnetic and which one is diamagnetic. Okay, so first let's see D10. So how you will fill the electrons in the d orbitals? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so you can see this, all the electrons are paired up. All the electrons, all the 10 electrons are paired up, means there is no unpaired electron. No unpaired electrons. If there is no unpaired electrons, it means it is diamagnetic. What is the magnetic nature? So it's a diamagnetic. Okay, suppose we have D6 configuration. Okay, any element which have D6 configuration. So let's fill the electron 1, 2, 3, 4, 5, and 6. 6. So you can see here in the D6 configuration, 1, 2, 3, 4. 4 unpaired electrons are present. 4 unpaired electrons are present. So if 4 unpaired electrons are present, so this is, what is the magnetic properties? It's paramagnetic. It's paramagnetic. Clear?
Yes, ma'am.
Okay. So paramagnetic, basically due to the unpaired electron, due to the presence of unpaired electrons, it is attracted by magnet. But a diamagnetic type of element are repelled by magnet because there is no unpaired electron which is present. Okay, unpaired electron absent hota hai, due to that it is repelled by magnet. Now, what is magnetic moment and what's the formula of magnetic moment and how we can calculate the magnetic moment? So magnetic moment is determined by the number of unpaired electrons. Okay, it is determined by the number of unpaired electrons and it is calculated by a spin only formula. And what is a spin only formula? This mu is equals to under root n into n plus 2. Okay, so this is the formula. Formula is very important. Just memorize this formula. So what is mu over here? So mu is your magnetic moment. Mu is magnetic moment. Okay, and what is N? So N is your number of unpaired electrons. Unpaired electrons. Okay. And what is the SI unit of magnetic moment? So SI unit of magnetic moment is Bohr magneton, BM. B, capital B and capital M, you will write as a SI unit of magnetic moment. And what is BM? Bohr magneton. Bohr magneton. Okay. For example, now tell me what is the atomic number of chromium, iron, manganese? Yes, Lubna, what is the atomic number of chromium? Anyone? Rindha, what is the atomic number of chromium? If you don't know the atomic number, how you will calculate the,
Ma'am,
how you will write
chromium
down the,
is 24.
yes, it's 24. It's very important to memorize the at least 30 elements. Starting ki 30, 40 elements ki you should remember. Okay, the atomic number. Or at least 40 नहीं तो 30 तक भी याद कर लो. It is very important. If you don't know the atomic number, how you will write down the electronic configuration? If you don't know the configuration, so how you will calculate the number of unpaired electrons? Yeah, so this is very important. So chromium has 24 electrons. The atomic number of chromium is 24. Okay, now just write down the electronic configuration. And iron atomic number is 26 and manganese is 25. Just write down the electronic configuration and let me know how many unpaired electrons are there in chromium, iron, and manganese. Just quickly. Yes, Ali, tell me how many unpaired electrons are there in chromium?
6.
Yes, very good. 6 unpaired electrons. So how you will calculate the magnetic moment? Mu will be under root 6 into 6 plus 2. It will be under root 48 bm. Okay. And yeah, Arinda, tell me what is how many unpaired electrons are there in iron?
Ma'am, 4.
Yes, very good. 4 unpaired electrons. So what will be the magnetic moment? So mu will be under root 4 into 4 plus 2. Okay, under root 24. 4 plus 2, 6. 6 goes up 24 bm. Okay, Hossia, tell me how many unpaired electrons are there in manganese?
5.
Yes, 5 unpaired electrons. Magnetic moment, accordingly, you can calculate. So 5 plus 2 under root 35 more magnet. Okay, is it clear now?
Yes, ma'am.
Okay, and the D block elements are generally paramagnetic due to the presence of unpaired electrons. So it's generally D block transition elements are generally paramagnetic, but there are some exceptions. Some exceptions, like in 3D series. In 3D series, what is the exception? So zinc is the exception. Okay, so you can see in the zinc, the all the d orbitals are completely filled. So it has D10 configuration. It has D10 configuration, and you can see in D10 configuration 1, 2, 3, 4, 5. So you can see all electrons are paired up. There is no unpaired electrons. Okay, so it's no, there is no unpaired electron, so it's a diamagnet. Okay, so most of the D block elements are generally paramagnetic because uh, all have unpaired electrons, but there are some exceptions. Okay, just like your zinc, your mercury, okay, your cadmium. So there are no unpaired electrons, so that's why they are diamagnetic in nature. Okay, okay, please quickly just do this question. Calculate the spin only magnetic moment of M2 plus ion, and the M atomic number is 27. Z is 27. Okay, and 27 किसको होता है? It's cobalt basically. So just write down the electronic configuration first. So it will be 1s2, 2s2, 2p6, right? 3s2, 3p6, 4s2, and your 3d7. Okay. Now this was for the metal M, but it is M2 plus. M2 plus means there is a loss of 2 electrons. Okay. So 2 electrons kahan se lose hoga? From this 4s, because it has less energy as compared to 3d. So it will be removed and you will get M2 plus configuration as 4s0 3d7. Okay. Now just calculate the unpaired electrons. So the configuration is D7. It's D7, 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5, and 6, 7. So how many unpaired electrons are there? 3 unpaired electrons. 3 unpaired electrons. So now use the formula. Mu is equals to under root n into n plus 2. Now just substitute the value of n over here. So what is n? So n is your 3. Number of unpaired electron is 3. So 3 into 3 plus 2. Okay, so 5 plus 5 multiplied by 3. So it will give you under root 15 Bohr magnetron. So that's how you will solve this type of question in your exam. Clear?
Yes, ma'am.
Okay. Next property is formation of colored ion. Formation of colored ion. So these transition metals, they form colored ion. Why they form colored ion? So it's a because when an electron from lower energy d orbital is excited to a high energy d orbital. So see here what happens here in this d block elements. So in the s block and in the p block elements kya hota tha? The transition was from the s orbital to the p. Okay, and from the p to d orbital. So different orbitals में transition होते थे. But in this case, in the d block elements, what happens? There is a transition, okay, means the electrons jumps from the lower energy of d orbital to the high energy of d orbital. Okay, means here the transition occurs between the d orbital and the d orbital. Okay, d and d. So this type of transition is known as dd transition. Okay, means the electrons from the lower energy d orbital, it jumps to the higher energy d orbitals. So this type of transition is known as dd transition. Okay, so when an electron from lower energy d orbital is excited to a high energy d orbital, what happens? यहाँ पे क्या होते हैं? The energy of excitation corresponds to the frequency of light. Okay, तो यहाँ पे क्या होते हैं? कुछ frequency of light get absorbed. When the transition occurs from lower energy to the high energy d orbitals, what happens? Some frequency got absorbed, and after some time, when this electron falls back to lower energy level, what happens? It emits radiation, and those radiations are in visible spectrum. Okay, generally those radiations are in the visible range, visible spectrum. So that's why we can see different colors. They just form different colors of compounds or ion. Okay, so these transition metals, again, this is due to the unpaired electron, okay, and due to the dd transition. Why it happens? Due to the dd transition, the electron jumps from the lower d orbitals to the higher d orbitals. Due to that, the energy gets absorbed, and after some time the electron loses this energy. Okay, so when it falls back to the lower energy, it emits some radiation, and that radiation is in visible region, visible range में होता है, visible spectrum में होता है, okay, which is with gear. Okay, so due to this process, which is dd transition, the different colors, the transition elements form different color ion, okay, or colored compounds. So due to this dd transition, copper salt का क्या color होता है? Blue color. The iron has green color. Okay, the iron के salts जो होते हैं, they are green in color. The copper salt is blue in color, right? And sometimes questions क्या आते हैं exam में? Why this copper has blue color salt and the iron forms green color salt, but zinc salt are white in color? Why? So you know very well zinc क्या होता है? Zinc has a D10 configuration. D10 configuration, there is no unpaired electron. There is no unpaired electron. So how the transition will occur? How the transition will occur? Because all electrons are basically basically d orbitals क्या होते हैं? They are completely filled. They are completely filled. They have no options for the transition. Okay, the electrons have no options for the transition. So then they don't show DD transition. In zinc, the electrons don't show DD transition. Okay, so due to that, the salt of zinc is white in color. They don't form colorful salts. Clear or not? Is this point clear?
Yes, ma'am.
Yes, ma'am.
Any doubt?
No, ma'am.
Okay, so each and every point is very important. So this is a theoretical type of chapter. So question can come from anywhere. Okay, like yahi se questions they can give you like zinc salt forms white color salt. Why? Okay, so it is due to the DD transition and you can explain it. What is DD transition? You can explain it and you can show it like it has a D10 configuration. Okay, and because it has a completely filled d orbital, so the electron don't show the DD transition. So due to that, zinc forms white colored salt. Next, formation of complexes. Okay, formation of complexes. So now what is complex? First, you should know what is complex. Anyone? Do you know what is complex? See, basically, complex कैसे बनते हैं? Complex are formed by a combination of Lewis acid, which is electron deficient, with the combination of Lewis base, which are electron rich. Lewis base क्या होते हैं? They are electron rich. So how complexes are formed? So complexes are formed by the combination of Lewis acid, okay, and the Lewis base. So basically you have learned in the coordination chapter, okay. So basically complexes क्या होते हैं? Coordination, when they form the coordinate bond, so they are complexes, coordinate complexes. So coordinate like complex compounds are those in which a metal atom or any ion bind a number of anions. When they bind a number of anions on neutral molecule, which gives a rise to complex species with characteristic properties. Okay, now what is complex compounds? So complex compounds are those compounds in which a metal atom, either metal atom or any ion, they bind a number of anions, okay, or neutral molecule, giving complex species with characteristic features, characteristics, properties, and they are also known as coordinate complex or coordinate compounds. Okay, for examples, you can see this is your iron. Okay, it's a metal, and when it make bond, this is your ligands. It is known as ligand. So this type of bond or this type of molecule is known as complex compound. Okay, this type of compound is known as complex compound. When the metal, okay, when the metal or any ion, it bind a number of anions or the neutral molecule. Okay, यहाँ पे कोई neutral molecule भी हो सकता है. Okay, and they form just some complex and they just form a coordinate bond. Okay, with specific features, with specific properties. Now, what are those properties? So, complex compounds have a tendency to form complex ions. Basically, transition elements की बात हो रही है, right? So, transition elements, which is a D block elements, okay? Not all the D block elements are transition elements, okay? Don't confuse in that. Only those which have unpaired, incompletely filled d orbitals. Those are only transition elements. So the transition elements have tendency to form complex ions or compounds. Why? Questions आ सकते हैं. Why transition elements form complex ions? So it is due to their small size. Okay, high charge on the transition metal ion. Third is availability of vacant d orbital of suitable energy which accommodate the lone pair electrons donated by the ligand atoms. Okay, so third point is very important. First one was due to the small size. Okay, they just form the complex ion. They are able to bind with the neutral atom or anions. Okay. And second point is due to the high charge on the transition metal ions, they are able to form the complex compounds. Third is due to the vacant d orbital, due to the vacant d orbital of suitable energy to accommodate, right? So transition elements, we know they have incompletely filled d orbitals. So if they have incompletely filled d orbitals, means vacant d orbitals of suitable energy, so they can electrons which are donated by the ligands. Suppose some ligands came and they just donate the electrons, so they can accommodate, basically the accommodate the lone pair electrons donated by the ligand atoms, and they can easily form the complexes. An example is it clear how they form the complex ion and why they form this complex ion? Everyone,
Yes, ma'am.
if there is any doubt, just please feel free to ask the question. Okay, यहाँ पे doubt नहीं होने चाहिए. Just clear your doubts now. If there is any question, you can just stop me and just ask your question. Okay, so question कैसे आ सकते हैं? Like why transition metals form complexes? Okay, so you know very well why they form the complexes due to the small size of the metal ions. Second is due to their high ionic charges. Third one is your availability of vacant d orbital. Okay, this is your penultimate d orbital, n minus one d. Okay, next one, catalytic property. Catalytic property. So most of the transition metals and their compounds act as, now first let's discuss what is catalyst. Do you know what is catalyst? Yes, Ali, what is
So
catalyst?
the,
Yes, Lubna.
it alters the rate of reaction.
They can only increase the rate of reaction.
Alter.
Yeah, they just alter the rate of reaction either by increasing the speed of reaction or by decreasing this. So there are two types of catalyst. Okay, those who just increase the rate of reaction and those who decrease the rate of reaction. Okay, so here how the transition elements act as a catalyst. So most of the transition metals and the compounds, they act as a catalyst. Why they act as a catalyst? Because of the variable oxidation state and the presence of vacant. Again the same thing. Again the presence of vacant d orbitals, due to which they form a variety of unstable intermediates. Now the catalysts are those, best catalysts are those which can make a unstable intermediate. Okay, because at last you have to make the product, and the catalyst has did not involve directly in the reaction, right? First, they just form the unstable intermediate, and if the transition, because transition metals have variable oxidation state. Okay, so they can form unstable intermediate, and after some time, the suppose you just give a catalyst involve हो रहा है, suppose any catalyst like any transition metal catalyst, so they just uh, involve in the they just alter the rate of reaction. Okay, and how they alter? First, they will try to make the unstable intermediate. Okay, between that reactant. Okay, and after some time, because this is unstable bond, first they will try to make unstable bond. Okay, and after some time, once the reaction speed is increasing or decreased, so after some time the bond will break. Okay, so bond कब break होगा? When it is unstable. When a stable bond formation कर लेगा, then it is unable to break the bond and you will not get the product. Okay, so the catalyst best वही होते हैं जो unstable intermediate को formation कर, right? So that's why transition metals and the compounds act as a catalyst. Why? due to the two reasons: oxidation, variable oxidation state, the presence of vacant d orbitals. Okay, next question. Yeah, so here the question, how the question can be asked: why transition element act as a catalyst? So due to the following reason. First reason is multiple oxidation state. Okay, and the second one is your tendency to form complexes due to the vacant d orbitals. They have a tendency to form various complexes. Why? Due to the vacant d orbitals. So these are the two reasons why transition metals act as a catalyst. Got my point?
Yes, ma'am.
Yes, ma'am.
Next is your formation of interstitial compounds. Formation of interstitial compounds. Now, first question is, what is interstitial compounds? So, interstitial compounds are those compounds. Suppose we have a solid lattice. Okay, this is a any molecule which is arranged in a solid lattice. So, here's in between there is a void. Here is in between there is a void. What happens in the interstitial compounds? So, those compounds which are formed when a small atoms here trapped here in the voids, like your hydrogen, hydrogen will trap here between the crystal lattice. Okay, or sometimes carbon or nitrogen, they got trapped inside the crystal lattice of metals. So these type of molecules which are formed when the small atoms like your hydrogen, carbon, nitrogen, they are trapped between the crystal lattice, inside the crystal lattice of the metals. So they are known as interstitial compounds. Okay, got my point? What is interstitial compounds?
Yes, ma'am.
Yeah. So, and they are non-stoichiometric. Now the question is, what do you mean by non-stoichiometric? The non-stoichiometric वो होते हैं a chemical compound whose elemental composition cannot be expressed by a ratio of small whole numbers. It means which violates the law of definite proportion. Law of definite proportion. Okay, because stoichiometric क्या होते हैं? Stoichiometric are those which follow the law of definite proportions. Okay, they can be expressed by a ratio of small whole numbers. Right. So non-stoichiometric क्या होंगे? Those compound whose elemental composition cannot be expressed by a simple whole number ratio. Okay, it means which violates the law of definite proportion. So those are stoichiometric. Yeah. So interstitial, the transition metals can form the interstitial compounds. Okay, they can form the interstitial compounds, the transition metals, and these interstitial compounds are non-stoichiometric. Okay, you can't express the elemental composition into a simple whole number ratio. So they are non-stoichiometric. And these interstitial compounds are chemically inert. Okay, they are non-reactive, they are chemically inert. Okay, so if they are chemical inert, so they have many applications. Okay, so interstitial compounds which are formed by the transition elements, they have many applications in day-to-day life, right? So they are chemically inert, they are non-stoichiometric, and definition, you know very well what is interstitial compounds. Next, alloy formation. Alloy formation. So alloy these transition metals because due to the similar atomic size. Okay, because you know the transition metals, some transition metals have very similar, approximately similar size. So due to the similar size, they just form the alloy. Okay, they form alloy, and suppose like your brass, bronze. Okay, so they just, and you know very well what are alloys. Alloys जो होते हैं, they are very hard. They are very hard, and their time melting point is quite high. Okay, why? Because they are formed by different mixtures. Okay, different elemental mixture. So alloy are basically homogeneous mixture of two or more elements in variable proportion. Okay, a large number of alloys are formed. Okay, the transition metals are able to form a large number of alloys. Why? Due to their similar atomic sizes. Due to their similar atomic sizes. And one more thing, the difference in the atomic size should not more than 5 to 15%. ये 5 से 15% से ज्यादा डिफरेंस नहीं होना चाहिए टू मॉलिक्यूल्स के साइज में. Okay, not molecules, to atoms के size में. Okay, so this is very important. So alloy will be formed when the difference in the atomic size will not be greater than 5 to 15%. Okay, this is the range. This is the range 5 to 15 का difference चलेगा. Beyond that, the alloy will not be formed. Okay, so it should be similar atomic size, and this would be in this range. Okay, alloys so formed are very hard with high melting point. Okay, and some examples are like brass. And what is the brass? Alloy of brass is basically made by copper and zinc. Okay, so brass किसका होता है alloy? So copper and zinc का. Similarly, bronze. So it's a alloy of copper and tin. Copper and tin. So it's bronze, and copper and zinc. So it's brass. And D block elements, they form alloys. Why? Because of approximately same size. Okay, and why same size? Due to the lanthanoid contraction. It starts. Okay, like when you starts from the group third series. Okay, so 3D series, 4D series, and after that 4D के बाद जो series आता है, the electrons get starts. You just start filling the electrons in the F orbital, 4F orbital. Okay, and here the lanthanoid contraction starts. Okay, so this is due to the lanthanoid contraction, and D block elements form alloys because of approximately same size. Clear, everyone?
Yes, ma'am.
Okay, so here the question is, why transition metals form alloy? Okay, so you can write these two reasons: due to the similar chemical properties. And chemical properties are, why chemical properties similar? Due to the approximately similar size. Okay, and size range should be in between 5 to 15%, not more than that. The difference should not be more than 5 to 15%. Okay, next one. Next is your ionization enthalpy. Okay, so before moving ahead, Rimdha, tell me, what is ionization enthalpy? What do we mean by ionization enthalpy? Yes? Anyone? Ali, what is ionization enthalpy?
The energy required to remove an electron.
Okay, remove which electron? The most loosely bounded electron. Okay, you will not remove the innermost electron, right? You will remove the outermost electron, which is valence electron. Okay, so what is ionization enthalpy? The energy required to remove the most loosely bound electron from a neutral isolated gaseous atom. That's the ionization enthalpy. So, uh, I think you know the regular train of ionization enthalpy, because you have already done this in your class 11. Right? So, although ionization enthalpy increases from left to right, regular trend क्या होता है? The ionization enthalpy increases from left to right in a period. Okay, so why it happens? So here it is due to the extra stability of D3, D5, and D10 configuration. There is regular variation in ionization enthalpy. So for the transition metals, because in the S block and P block, the regular trend is basically it increases. It increases, but because here the transition metals includes the uh, filling of electron in the d orbitals. So, and you know very well, अभी तक हमें क्या पता था? The incomplete, you're half filled, exactly half filled. D5 and D10 configuration are most stable, right? अभी तक हमें ये पता था D5 and D10 are most stable. Okay, your exactly half filled, which is D5, and completely filled electronic configuration is most stable. But just remember here D3 is again D3 is most stable. Okay, D10 is most stable, but between D5 and D3, D3 is more stable than D5. Okay, just keep this in your mind. D5 से ज़्यादा stable कौन सा होता है? D3 configuration. So if some metal or some any element is in D1 configuration. Okay, so it will try to achieve D3 configuration because it is more stable. And you know very well, everyone in this world and in chemistry also, everyone try to achieve more stability. Okay, towards more stability. So if it is D1 configuration, so it will try to achieve D3 configuration. Why? Because D3 is more stable. Okay, it will try this D1, it will try to gain 2 electron. ये 2 electron क्या करेगा? Try करेगा gain करने का, and it will try to achieve this stable configuration, which is D3. Suppose we have D4 configuration. Any metal have D4 configuration, but this D4 is not as stable as D3 and D5, right? It's close. It's close. Stable electronic configuration is D3 and D5, right? So ये क्या करेगा? Either it will lose one electron and it will achieve D3 configuration, or either it can gain 1 electron and it can achieve D5 configuration. Both are equally stable, but D3 is more stable as compared to D5. Clear? Yes or no?
Yes.
Okay. So ionization, basically ionization enthalpy increases from left to right, but this transition for this D block elements, there is no particular trend for the ionization enthalpy. For this ionization enthalpy, there is no particular trend because it depends on the extra stability of D3, D5, and D10. Okay, so if it is the electronic configuration is D3, so it will be more stable. Okay, and if it is more stable, more energy will be required to remove the loosely bounded electron, right? Because this is more stable. Stable है तो ये क्या करेगा? It will not easily आप electron remove नहीं कर सकते from this D3 configuration. Okay, so more energy will be required. More energy will be required to uh, uh, remove the electron from the outermost orbit, right? Similarly, D5, D10 maybe. So that's why in ionization enthalpy of transition elements does not follow any trend, any regular trend. Where the D3 configuration come, ionization enthalpy increases. Okay, where the D5 configuration come, ionization enthalpy increases. Okay, so it's for the ionization enthalpy of transition metal, there is no particular trend. Okay, so there you will see regular variation in ionization enthalpy. Regular variation in ionization enthalpy. Okay, let me show you one picture here, which is from the NCERT. Okay, is this visible? See here.
Yes,
Yeah.
ma'am.
See, this is your ionization, first ionization enthalpy. It's the 3D series. It's the data of the 3D series only. So, scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc, and so on. Right. So, you can see first ionization enthalpy, second ionization enthalpy, and the third ionization enthalpy value. See here. So, you can see 631. Scandium का first ionization enthalpy was 631. After that, titanium will have ionization enthalpy 656. After that, vanadium का decrease हो जाता है 650. Okay, it got decreased. So you can see it does not follow a regular trend. After that, chromium ka it's 653, which is very less. Okay, which is less than the titanium. Then manganese, it becomes more like 717. Why manganese ko kya ho jata hai? Because manganese has a D5 configuration. Manganese has a D5 configuration, and D5 configuration is most stable. Is more stable, right? So that's why ionization enthalpy kya ho gaya? अचानक increase हो जाता, right? More the energy required to remove the electron from the outermost orbit due to the stable electronic configuration. After that, iron 762, then cobalt 758, okay, and so on. So you can see here, there is not a regular and particular trend for the ionization enthalpy. And why? Why it is? So it is due to the extra stability of D3, D5, and D10 configuration. So got my point?
Yes, ma'am.
Any doubt in this?
No.
Okay. Okay. So now see, generally we know in a period from left to right, ionization enthalpy क्या होता है? It increases. Why it increases? Because the size decreases. Now see, if the size decreases, because when we move from left to right, what happens? The size decreases. So if the size decreases, what will happen? There will be a more force of attraction between this nucleus and the outermost electron. Okay, that's why size decrease हो रहा है. There will be more attraction, right? If there is more force of attraction, then because this is not very much loosely bound, okay, this is very much indulged in the force of attraction, okay, in the force of attraction between this proton, okay, because proton is present in this nucleus, right? So there is more, if the more force of attraction is there, then the size will decrease. So in a period when the size decreases, when you move from left to right, what will happen? Ionization enthalpy will increase, okay, because more energy will be required to remove this electron, because the force of attraction between this outermost electron and the nucleus. Okay, here the force of attraction is more force of attraction. That's why size becomes reduced. Size छोटा होता जा रहा है. Got my point?
Yes, ma'am.
Yes, ma'am.
Similarly, in a group, when you move from top to bottom आप जा रहे हो, तो what happens? The size increases. Size increases means the number of shells increases. If the number of shell increases, see, if the number of shell increases, what happens? The electrons, see, this is, suppose this is your outermost electron. So there will be a more electrons, okay, on the inner electrons. So due to that, there will be more shielding effect. There will be more shielding effect. These electrons will act as a shield, okay, and they will not try to, they will basically they will intervene between the force of attraction between this outermost electron and the nucleus. Okay, so here when the size increases, the screening effect of shielding effect increases, and if the shielding effect increases, it will be very easy for the it will be very easy to remove the outermost electron, because here the force of attraction between the outermost electron and the nucleus is not as much as compared to this one, because here the size chota tha, and if the size is small, so there will be more force of attraction and less screening effect. Here less screening effect was there, so the ionization enthalpy zyada ho raha tha, means the energy required to remove this electron will be more, and here less energy will be required to remove this electron. Easily you can remove the electron from the outermost orbit, okay, due to the bigger size, due to the bigger size. I hope my concept is clear.
Yes,
Is it clear? Okay.
Ma'am.
Yeah. So the transition elements does not follow any regular trend, okay, or particular trend for the ionization enthalpy due to the extra stability of D3, D5, and D10 configuration. Okay, let's do some question. It's quite interesting. Which is the stronger reducing agent, chromium 2 plus or Fe2 plus, and why? Just think about it and just let me know. Let's see who will answer first. Stronger reducing agent between chromium 2 plus and Fe2 plus. See, that's why I just told you why memorizing the atomic number is very important. If you don't know the atomic number, how you will write down the electronic configuration? And if you don't write down the electronic configuration, how you will get to know whether the electron, it will lose electron or gain electron to achieve more stability? And how you will get to know whether it's a reducing agent, stronger reducing agent, or weak reducing agent? So each and everything depends on the atomic number. So it's very important to learn the atomic number. So sometimes in your exam, it will be given the atomic number is this, but sometimes it will not be given, and no one will going to tell you what is the atomic number. Now, just quickly do this question. Yeah, who will tell me? No one? Okay, let me ask you. Now, first, let me know who will, yeah, Lubna, tell me, what do you mean by oxidation and reduction?
Sorry, ma'am.
What do you mean by oxidation and reduction?
It is the addition of O2 and reduction of H2.
Addition of H2 is the oxidation.
No, ma'am. Removal.
Yes. And what about the electron? In terms of electron, in
Uh,
oxygen, yes.
compound gaining electron and reduction and decrease in its oxidation number.
No, no, oxidation is the loss of electron. Oxidation is the loss of electron and the reduction is the gain of electron.
No, ma'am, I was saying reduction.
Okay, so reduction is gain of electron and the oxidation is loss of electron, and oxidation is basically addition of oxygen and the removal of hydrogen. Okay, and here it is just opposite, removal of oxygen and the addition of hydrogen, right? That's the oxidation and reduction. Now, what do you mean by reducing agent and oxidizing agent? So let only discuss the reducing agent first. So what is reducing agent? Yes, Hosia, do you know what is reducing agent?
Uh, the one that helps in oxidation. The one that helps in reduction.
Yes, the one that helps in the reduction. Basically, reducing agent are those agent which reduces the others but oxidizes itself. खुद को ऑक्सीडाइज करता है but it reduces others. Okay, so that's the reducing agent. Okay, so let's see how to do this question. This is very important. Just see here. So always start from writing the electronic configuration. So it's chromium. So what is the atomic number of chromium? So it's 24. So it will be argon. Okay, 4 is 2 and 3d4. Okay, that's the electronic configuration. But it is chromium 2 plus. It's chromium 2 plus means 2 electrons from the 4s. It will be removed and you will get argon 18, 4s0 and 3d4. Okay. Now what about the magnet iron? So it's Fe. First you will write on the Fe. What is the atomic number of Fe? 26, right? So write down argon 4s2 3d6. Now Fe2 plus will be, it's argon, right? 4s0 and 3d6. Now, what do you mean by reducing agent? Reducing agent are those which oxidizes itself. खुद को क्या करेगा? Oxidize करेगा. Oxidizes itself. Oxidizes itself means there will be a loss of electron. Oxidation means loss of electron, right? Not gain. So the reducing agent are those agent which loses its electron, okay, and it oxidizes itself. Okay, now let's check it. So if see chromium 2 plus, so it will basically lose electron, oxidize, because reducing agent kya karega? It will oxidize itself. Oxidize itself means it will lose an electron. So chromium 2 plus, if it is chromium 2 plus, lose karega electron, so it will become chromium 3 plus. Clear? Clear or not?
Yes, ma'am.
Okay, because when it lose one electron, तो इसपे क्या होगा? +3 charge. Okay, so 2 plus. So now see the configuration over here. If it was D4 configuration, so after losing one electron, it will become D3 configuration. Yes or no?
Yes, ma'am.
Okay, now check it for iron. Let's check it for iron. So Fe2 plus. So again, both are reducing agent. It's given here. You have to check which one is a strong reducing agent. Both are reducing agent, it's known. So when Fe2 plus, it lose one electron, if it will become Fe3 plus. Okay, so first in Fe2 plus, what was the configuration? It was D6. D6 से क्या बन रहा है ये? D5 configuration. So here the D5 configuration and it is D3 configuration. Now tell me which one is more stable. D3 configuration or D5? Yes, D3. As I told
D3.
you. Yeah, D3 is most stable than D5. So what will be your answer? What will be your answer? The chromium 2 plus, if it is more stable, so it will easily oxidize, right? If it is more stable, तो ये easily oxidize हो जाएगा, and if it is easily oxidize हो रहा है, तो it is a strongest reducing agent. Okay, between these two, chromium 2 plus is strong reducing agent. So you can write the conclusions. Chromium 2 plus will easily oxidize itself and is strong reducing agent as compared to Fe2 plus. There, everyone clear? Ali, Rimda?
Yes, ma'am.
Yes, ma'am.
Okay, now let's see this question. Why is the highest oxidation state of metal exhibited in its oxide or fluoride only? Why? The question is why the highest oxidation state of metal is exhibited in its oxide or fluoride only. So write down the answer is due to the most electronegative, because if you see the periodic table, which one is most electronegative? Fluorine. After fluorine, oxygen, right? So oxygen, and why? Because oxygen and fluorine are most electronegative elements. So when the transition metal try to make the compounds, okay, try to make the compounds like your MnO4, MnO4 minus, MnO4 minus. So you can check the oxidation state here in this manganese oxide. Just find the electron oxidation state. So it will be X plus 4 to the 8 and here minus 1. So it will acquire plus 7. Okay, so basically in Mn4O4 minus, manganese has plus 7 oxidation state. Okay, so plus 7 oxidation state of manganese is highest oxidation state of the whole transition element. Okay, or of the whole series like 3D series. 3D series में manganese का सबसे highest oxidation state क्या होता है? Plus 7. And it when the plus 7 oxidation state exhibit when it forms a oxide. Okay, metal oxide, manganese oxide जब बनाता है ये, or either manganese fluoride. So when it is combined with either oxygen or fluorine, because these two are most electronegative element in the whole periodic table, so they have a tendency to pull the electron towards itself more strongly, right? So that's why they will the more oxidation state or highest oxidation of a state of metal exhibited when the transition metal try to make bond with the oxygen or either fluorine. Okay, means when they make oxide or fluoride, so they have highest oxidation state. An example is manganese oxide. Other example you can write your potassium dichromate. ले सकते हो आप, तो डाइक्रोमेट में क्रोमेट आयन Cr2O7 minus 2 ion. Okay, just try to find the oxidation state of chromium. So it will be 2x plus 7 into minus 2 is equals to minus 2. So it will give plus 6 oxidation state. So chromium will have plus 6 oxidation state over here. Cr plus 6. Again, you can see chromium when it makes bond or when it forms the oxide. Okay, chromium oxide, dichromate oxide basically. So it will acquire highest oxidation state. Okay, so that's the reason why the highest oxidation state of metal exhibited in its oxide or fluoride only, because the oxygen and fluorine are most electronegative elements, so they can easily make bond or make a strong bond by pulling all the electron towards itself, so that the highest oxidation state of metal exhibits. Clear?
Yes, ma'am.
We see the next one. Why chromium 2 plus is reducing agent and manganese 3 plus is oxidizing agent when both have D4 configuration? Now you guys will tell me what will be the reason. Just solve this question. Just use your mind. You know how to do this question. If you know what the concept of oxidation reduction, reducing agent, oxidizing agent, so you can easily do this question. Okay, just solve this and let me know who will tell me the first.
Yes, done. Yes, Lupna, tell me the answer. Anyone? Okay, see, see this is your chromium 2 plus. Okay, so it has D4 configuration. Okay, it has D4 configuration. So why chromium is reducing agent? Question is why chromium is reducing agent. So why it is reducing agent? Because chromium has, it will lose one electron. Okay, it will lose one electron and it will try to achieve most stable configuration, which is D3 configuration. And what about the manganese 3 plus? So it is an oxidizing agent. So it again has a D4. Oxidizing agent means it will reduce itself. Okay, it will reduce itself. Reduction किसका होगा? खुद का होगा, means the gain of electron. If it is gain of one electron, so it will be Mn2 plus. Mn2 plus means your D5 configuration. Okay, and why this happens? Why chromium 2 plus lose one electron and manganese 3 plus gain one electron? So you know very well when you move from, because chromium atomic number is 24 and after chromium manganese up 25. And you know very well when you move from left to right, what happens? Ionization enthalpy basically increases. Okay, it increases. Generally, it increases. Why it increases? Due to the more Z effective, more nuclear charge. Nuclear charge क्यों increase हो रहा है? Due to the decrease in size. Due to the decrease in size. So if the size of the atom decreases, what will happen? The Z effective will increase. Okay, and if Z effective is effective nuclear charge. If effective nuclear charge increases, means there will be a more attraction between the outermost electron and the nucleus. Okay, between the proton of the nucleus. So if there is more attraction, so the ionization enthalpy will increase. The energy which is required to remove the outermost electron will be more. More energy will be required. Okay, and if more energy will be required, so how it will lose one electron? Lose कैसे करेगा, right? So here in the manganese, ionization enthalpy basically from chromium to manganese increases. If increases, why it increases? Due to the increase in size. Decrease in size, because when you move from left to right, size decreases. Size decreases, right? If size decreases,
what will happen? Effective nuclear charge. Nuclear charge क्या होगा? Increase हो जाएगा. If nuclear charge increases, there will be more attraction between the outermost electron, which is negative, and the positive, which is proton. Okay, इन दोनों के बीच में more force of attraction will be there. If more force of attraction will be there, then how you will remove one electron? Lose कैसे होगा? How the lose of electron will occur? Right? If lose nahi hoga, it means that it will not act as a reducing agent. So it will act as a oxidizing agent. It will act as a oxidizing agent. So that's why manganese act as a oxidizing agent, and chromium, which has less ionization enthalpy as compared to manganese, it will act as a reducing agent. Okay, but because when you compare these two, chromium and manganese, so it will be easy to remove electron in chromium. Okay, so here in chromium, loss of electron can be done very easily. Okay, and here in manganese, loss nahi ho paega. Why? Because ionization enthalpy in manganese is more. Okay, so here if the loss of electron does not occur, it means यहाँ पे gain of electron होगा. And if gain of electron हो रहा है manganese में, it means it will act as oxidizing agent. It will act as a oxidizing agent. Clear?
Yes, ma'am.
Next is your oxidation state. Okay, so transition elements, they show a large variety of oxidation state. Okay, except the first and the last element of the series. First and last element of the series, उसे छोड़ के otherwise all the elements show a variety of oxidation state, +2, +3, +4, and so on. Right? So the most common oxidation of the transition element, basically first transition series, which is 3D series. 3D series, which starts from the scandium. Atomic number is 21. Scandium to zinc. Okay, the atomic number of zinc is 30. So this is the first series, which is 3D series. Okay, so I'm just talking about the 3D series. So the most common oxidation of the 3D series is +2. Okay, +2, except scandium, because scandium का +2 नहीं होता, it's +3 oxidation state, and yeah, except scandium, all have the +2 oxidation state. So that's why most common oxidation state of first transition series, which is 3D series, is +2. Okay, except scandium. Exception is scandium. Scandium की only +3 exists. See, you can see this data, this table over here. So this is the oxidation state table of the first series, which is 3D series. Okay, so you can see scandium. Scandium has only one oxidation state, +3. Okay, and the zinc has only one oxidation state. Okay, that's why I have written this point. Transition element exhibits a large variety of oxidation state, except the first element, which is scandium, and the last element, which is zinc. Okay, because we are talking about the 3D series here only. So this is the data of 3D series. And you can see manganese. Manganese has the highest oxidation state, which is +7. Okay, and highest oxidation state of manganese will exhibit only in either oxide or fluoride. So that's why MnO4- will have the highest oxidation state, which is +7. Okay, for manganese. Is it clear?
Yes, ma'am.
Okay. Next, the transition elements in the lower oxidation state. In the lower oxidation state, which is +2 and +3, they usually forms ionic compounds. Okay, if the transition elements are in the lower oxidation state, like +2 or +3 may exist करेंगे, so they just form ionic compounds. But if the higher, so in the transition elements in higher oxidation state, means more than +3, +4, +5, +6, and +7. Okay, so they just form covalent type of compounds. They form covalent compounds. Only osmium and ruthenium show +8 oxidation state in their compounds. Okay, so osmium, which has atomic number 76. Okay, 76 होता है and it belongs to the 5D series. 5D series means sixth period. Sixth period. And again ruthenium. So ruthenium, it belongs to the, basically it atomic number is 44 and it belongs to the 4D series. It's 4D series and this is 5D series. So both have only these two, osmium and ruthenium, has +8 oxidation state in the whole transition element. Okay, and in their compounds. Nickel and iron in NiCO4, okay, and FeCO5, these two compounds. And these two compounds are the example in which nickel and iron has zero oxidation state. Okay, nickel and iron have zero oxidation state. Got my point?
Yes, ma'am.
Okay, now the second last property, which is trends in the standard electrode potential. Now, what is the trend of transition element in the standard electrode potential? So basically, generally, it increases from left to right across a period, but in between, it shows some irregular trend. Why? Due to some factors like ionization enthalpy, due to the your extra stability of D3, D5, D10 configuration. Okay. So basically, it again the standard electron potential का भी कोई exact आपका trend नहीं होता है. Starting में it generally increases. Okay. In starting, it generally increases, but in between it shows irregular trend. Why? Due to some factors like ionization enthalpy, enthalpy of atomization, which is also known as melting point, and the stability of a specific oxidation state. Okay, the specific oxidation state, because here you can see, which is bold black color se jo mention hai, this is the stable oxidation state of each element. So titanium, okay, this titanium exists. A most stable oxidation state of titanium is +4. For vanadium is +5. For chromium it's +3 and +6. Manganese it's +2 and +7. Iron, these two +2 and +3. Your copper, sorry, this is a cobalt. It's a +3, +2 and +3 both. And nickel carrier, this +2 is the most stable and most common oxidation state of nickel. Similarly for copper and zinc. Okay, so this bold color se jo bold black se likha hua hai, this is the most stable oxidation state of these elements. Okay, you should remember this. So this is again important chart. Yeah. So why the irregularity in the trend of standard electrode potential? Due to these factors: ionization enthalpy, enthalpy of atomization, and stability of specific oxidation state. So basically, metals with higher ionization enthalpy or enthalpy of atomization tends to have more positive value of E. Okay, so those metals which have higher ionization enthalpy and the enthalpy of atomization, they will have positive standard electrode potential values. Okay. Last one. Trends in the stability of higher oxidation state. Okay, so trends in the stability of higher oxidation state. Okay, so in transition metals, stability of higher oxidation state increases. Why? Increases across a period to a maximum and then decreases. Okay, again you can see the chart over here, this data. So see, again, let's see the 3D series. So you can see it from a scandium. From a scandium, what happens? It first increases, okay, up to the manganese. Manganese तक क्या हो रहा है? The oxidation state, highest stability of higher oxidation state, it increases. +3 was for scandium. Then titanium का highest क्या था? +4. Vanadium +5. Then okay, so first it increases, and after manganese it decreases. Now the question is why it decreases? Why it decreases? So again, it depends on the number of unpaired electron. Let's see. It's very interesting. Let's see again. Yeah. See. So suppose we have, let's talk about the 3D series. 3D series की बात करते हैं. So it starts from the scandium, then titanium, okay, titanium, vanadium, chromium, manganese, then your iron, cobalt, nickel, copper, zinc. Okay. So in scandium, 21, 22, 23, 24, 25, 26, 27, 28, 29, and 30. Now tell me, what is the configuration of scandium? Outermost configuration only. Outermost configuration of scandium. Yes, Rimda, tell me. D4, D5, just like that.
Beyond 1920. Ma'am, is 4s.
Last electron will goes in. Only D configuration, tell
4.
me. D4.
3.
Are you sure it's D3? Is she correct, Ali?
No, ma'am.
So what is the, how many electrons will be there in 3D orbital?
Only one electron.
Yes, very good. Only one electron. So you will write D1. Okay, so again, the stability of higher oxidation depends on the number of unpaired electrons. So in the scandium, the configuration is D1. Configuration kya hai? It's D1. So when you draw the orbital, d orbital, 1, 2, 3, 4, 5, so 1. So you can see only one unpaired electron is there. Similarly, for titanium, it is D2. For vanadium is D3. Chromium is D4. And maximum, now see, maximum unpaired electron in the d orbital could be 5. 5 से ज़्यादा होंगे तो it will be paired up, right? So maximum number of unpaired electron is in manganese. That's why manganese show a variable oxidation state, most variable, and you can see +7. It is the maximum oxidation state along a series. Manganese show maximum oxidation, highest oxidation state in its series. Why? Due to the maximum number of unpaired electron. Maximum number of unpaired electron in d orbital could be 5. D5 से ज़्यादा तो नहीं होंगे. If it is D6, so after 1, 2, 3, 4, 5. So after 5, it will be paired up. Okay, 6 क्या करोगे आप first में fill करोगे and you will get only 4 unpaired electron. Okay, so maximum unpaired electron can be 5, not more than that. So you can see here in 1, 2, 3, 4, 5, 1, 2, only 2 unpaired electrons are there. Then in this vanadium, 1, 2, 3, 4, 5, only 3 unpaired electrons are there. In chromium, 1, 2, 3, 4, 5, only 4 electrons are unpaired. But in manganese, there are 1, 2, 3, 4, 5, 5 unpaired electrons. Okay, maximum unpaired electrons you can see in the manganese. That's why it shows maximum number of oxidation state, maximum or higher oxidation state. Similarly, iron. So that's why, see the trend. Let's first discuss this. So iron में क्या हो जाएगा? It's D6. Cobalt, it's D7. Nickel is D8. Copper is D9. And zinc again is D10. Okay, so when you draw the orbital, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, and this 6. So we can check it. 1, 2, 3. How many unpaired electrons? 4 unpaired electrons. Clear? Now similarly, cobalt का draw करो. 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5, 6, and 7. Now how many unpaired electrons? 3 unpaired electrons. Similarly, in nickel, it will be 2 unpaired electrons. In copper, it will be only 1 unpaired electron. And in B10, 0 unpaired electron. 0 unpaired electrons. Okay, so that's why it depends on the number of unpaired electron. More the number of unpaired electron, more will be the oxidation state, or higher will be the oxidation state. That's why the trend ट्रेंड क्या होता है ऑक्सीडेशन स्टेट का? फर्स्ट इट इंक्रीजेस फ्रॉम scandium to manganese. From scandium to manganese, it will increase because the number of unpaired electron is increasing, right? 1, 2, 3, 4, 5, then 6. After 5, it is in manganese, it is the maximum number of unpaired electron. After 5, after manganese, the electrons got paired up and you will get only 4 unpaired electron, then 3 unpaired electron, then 2, then 1, then 0. So that's why you will see this trend. First, it will increase from scandium to manganese. Maximum यहाँ तक increase होगा, and after manganese it will decrease. Why? Because the number of unpaired electron it decreases. I hope it is clear now.
Yes, ma'am.
Any doubt?
No, ma'am.
Okay. Okay, so this is the point. In transition metals, stability of higher oxidation state increases across a period to a maximum and then decreases. To a maximum कहाँ तक होता है? Till manganese. This is due to the increasing number of unpaired electrons up to manganese and a greater stability of half-filled or fully filled d orbitals. Okay, so half-filled and fully filled d orbitals are stable. Okay, now the question is why zinc does not show higher oxidation state or variable oxidation state. Okay, so again we have learned that there is exception. The oxidation state basically it has a variable oxidation state except the first and the last. Zinc का D10 होता है, okay, D10 configuration होता है, and it is most stable configuration, but it does not exhibit a large variety of oxidation state due to zero unpaired electron. Okay, due to no unpaired electron. I hope my point is clear to everyone.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay, okay, so we have completed all the characteristics. These are the 12 characteristics of transition elements. Now, 2 topics are left. I think, inshallah, tomorrow we will complete that. We have some important compounds of transition elements. So, in this, we will learn about the K2Cr2O7, potassium dichromate, and potassium magnate, permanganate. Okay, so in this we will see the methods of preparation. Okay, some questions we will discuss, and a structure हम देखेंगे. What is the structure of chromate ion? Okay, chemical properties. Okay, and similarly for the cheminophore also, it will not take much time. I will complete your chapter by tomorrow. And after that, we will discuss inner transition elements. In that, we will discuss 2 series, lanthanoid series, actinoid series. Okay. And we will discuss some points like general properties, what's the oxidation state generally for actinoids as well as the lanthanoids. And basically from this point, from this topic, sometimes questions direct comes like differentiate between lanthanoids and actinoids. And what do you mean by lanthanoid contraction? And what are the consequences of lanthanoid contraction? So these type of question इनसे बनते हैं. So, okay, so that's all for today. I just stop it here. We will cover this, or we will complete this chapter by tomorrow, inshallah. If you guys have any doubt, just ask your doubt. Just ask me now. Any doubt?